Okay, good morning everyone. Today we will see of prestressed concrete. One second. I'm audible.
Yes, sir.
Yes, sir.
So instead of going for a slide share, I have made extended this one so that easily I can use different types of pens and I can have used the highlighters because in this is a 2007 one. I don't have much features in this, so I will try to present it outside only. So today we will see about the first unit about SP3, and this is the very basic unit. And if you want to understand anything, means the basic things, basic concepts are there. If you want to understand this basic concept, then the further three units, that is second unit and third unit, will be very difficult for you. Okay, so I will explain in a very smooth way. Try to understand and try to grab the thing. If you find any difficulties, then you can ask me at any time. And this is the very basic unit. Okay, just keep it in mind. And numericals are there. Numerical also on the direct formulas are there, not that much complicated ones. Easy formulas are there. So today we will start with the first unit. Okay. So the first unit, that is analysis of prestressed concrete members. Okay, prestressed concrete members. So directly going into the things, we will go step by step. PS is nothing but prestressed concrete. Okay, just remember in mind and don't confuse with the pretension and post tension. Okay. PSC is nothing but pre-stressed concrete. Okay. And in this we have two types, that is pre-tension and post-tension. That is if this is your beam, if you are initially giving the tension to the cables, okay, or directly going to that one, just now I will say about the rods. Okay, in RCC structures, okay, we will provide the rods, correct? These are the stirrups. Okay, so in pre-stressed concrete members, we use sometimes we use 8 rods, or we have cables, okay, tendons. So we have different types. We will see further, but now just remember that if you are giving tension, okay, to the rods, initially means that is called as pretension. If you are providing the tension after words means that is called as post tension. So we will study about this one in very deep in further slides. So the thing is that don't confuse about pretension and post tension. Okay, keep it in mind. So history, use of steel wires with ultimate strength as high as 1275 megapascal. Okay, you know what is megapascal? Just recall whatever you have learned in the RCCs. Okay, mega is nothing but 10 power 6 and 1 pascal equals to 1 into 10 raised to minus 6 Newton per mm square. Okay, don't forget the basic things. And yield strength of 1240 megapascals. Okay, he is actually the father of prestressed concrete. His name is Ion Ernest. Okay, he is called as the father of prestressed concrete. He developed a conical wedge, okay, for an end anchorage of post tensioning and develop double action jack. Okay, we will see what do you mean by jack, wedges, anchorage system. Okay, we will see about all those things. He often referred as the father of prestressed concrete, and other scientists have also developed different types of pretensioning methods. Okay, so here we can see. So in olden days, people used to store the wines, alcohol or water. Okay. So here you can see these are the wooden stakes. Okay. These are nothing but the wooden stakes, and these are nothing but the steel bands. Okay. If you take this section outside only one wood, it will be like this. Okay. They will be individual stakes like this. What they will do, they will put this wooden in the hot water, hot boiling water, such that this wooden will be become flexible and they will bend it. Okay, they will bend like this. Okay, they will bend like this, and this is still whatever you see. Actually, the size it will be. If I take like this here, okay, and this is my steel band. Okay, so actually if you directly put it, okay, without heating, it will come up to this point. And you know that the property of steel, okay, steel expands on heating and contracts on cooling. Okay, you know this basic thing, property of the steel, that is steel expands on heating and contracts on cooling. So what they do is that they will heat this steel band. Okay, after heating what happens, it try to expand like this. Okay, it will expand. Okay, afterward, afterwards, what they do, they will insert this steel band into these wooden stakes, and it will come up to this point. Okay, so after coming to that point, what they will do, they will cool down that steel band. Okay, after cooling down steel band, what happens? It tries to contract. Okay, what it happens? It tries to contract. Means the tensions are created. I will show images also. The It will be hard for me to clear everything. Okay, it starts to contract, and it will hold very tightly. Okay, this will hold very tightly. All the units of wooden stakes, it will hold very tightly. The best example is that you have a bundle of notes. Okay, say there are 100 notes. What you do? You apply the rubber band. Correct. What you do? You just apply the rubber band. So what it do? It holds all the nodes together. So this is the actual thing of this tensioning. Okay. Here also you can see this is the wheel of a cart. Okay. These are the individual structures. Here you can see from here to here it is one part. From here to here it is another part. From here to here it is another part. Okay. How many parts are there? 1, 2, 3, 4, and 5. Okay, so if you are from villages or if you have observed the cart, so here you can see this is iron casing. Okay, which is embedded around the perimeter or the circumference of the wheel. Okay, so before installing, okay, if I clear everything, so if you directly go and put this iron casing, it will come at this position, means the circumference will be smaller. See, this is your wheel. Okay, and this will be your iron casing. So what they will do, this is your wheel and this is your steel. Okay, so what they will do, they will heat up this one. So you know the property of the steel, after heating it expands. Okay, so this is our wheel, and after expanding it will be the same size. So what they will do, they will cover the circumference of the wheel with the steel. It will not be that much gap, it will be like this. Okay, once it is fitted, what they will do, they will apply the water. Okay, so you know that after cooling, what happens, the steel contracts, it start to gaining its original position. So during that time, this is the actual size and this is the size after heating. So the size of the steel wants to come to this shape or this size, but this wheel is preventing to reduce that size. So what happening, the tension is happening on the wheel. So that is how it holds all the planks togetherly. Okay, these are the olden methods. From these things the actual pre-stressed concrete has been originated. Okay, these are the some examples. Okay, nowadays you can see the metro construction. Okay, any bridges, flyovers. Okay, if you take any huge structures, nowadays they are coming with the pre-stressed concrete. Okay, why? Because They can carry huge load. Okay, the construction will be faster. So advantages we will see further. Okay, so these are some example. Panam Bridge Road at Rameshwaram. Okay, you can see which is road over the sea. So it is also built by the pre-stressed members. Okay, pre-stressed members. Members means it may be slab, beam, column, etc. Okay, so here also you can see this is a bridge, okay, which is pre-stressed beam. This is also you can see, if I cut this part, this is one beam. I should call it as a girder. Okay, this is the second part. Here also you can see the column. So nowadays whatever you are seeing is of pre-stressed members. So the general principle of pre-stressing barrel constructions. Okay, initially I have said that. Okay, how it works. When rope or metal bands or steel bands were wounded around the wooden stakes to form a barrel. So these will be the individual stakes. Okay, these will be the individual stakes. Total 10 woodens are there, for example. So what we do, we lay them in a circular way and we apply this steel band or metal band. When the bands were tightened, okay, how you tighten that one? So starting what you do, you heat it, steel expands. Okay, after bringing this steel band to this position, what you do, you cool it. So after cooling, what happens? The contraction will happen. So when the bands were tightened, they were under the tensile pre-stress, which in turn created the compressive pre-stress between the staves and thus enabled them to resist the hoop tensions. Okay, so whenever you apply this steel band over the staves, sorry, what happens? There creates some tensions. Okay, in other words, the bands and the staves were both pre-stressed before they were subjected to any service loads. For example, if you take one beam, okay, simple example, this is a simply supported beam and this is a RCC structure. So after casting and after everything, you apply the load. Say apply uniform load or UDL load, UVL load, any type of load. So the sorry, the beam get deformed like this. Okay, very simple example. After application of the load, the beam get deformed in this way. Okay, but in pre-stressed concrete, what we are doing, we are providing initial tension. Okay, initially it will not be this much. Initially your beam will be like this. Okay, after application of the load, it will become like this. Okay, after the application of the load, it will become like this. But our RCC was initially it was like this, then it sagged after application of the load. But in our pre-stress, initially we provide some tension. Okay, when load acts upon it, it counteracts. Remember the word, it counteracts and it keeps in this way. Okay, now very important terminologies. Okay, remember for MCQs or for offline, Very important. What do you mean by tendons? Okay. A stretched element used in concrete member of a structure to impart pre-stress to the concrete. So initially I have said that we use in RCC we use rods, okay, but in pre-stressed concrete we use tendons. Okay, it is a stretchable element. Okay, we can stretch it while passing through the uh, concrete. We can stretch it. Either it may be a pre-stress or post-stress. A stretched element used in a concrete member of a structure to impart the pre-stress to the concrete. Then what you mean by anchorage? See, now what I do, this is my concrete member. I have passed one tendon or wire, cable, etc. Whatever. What I will stretch it. Means I provide tension to the steel. Correct? So what happens? Someone should be there. Okay. See, say that one person is pulling this side and another one person is pulling this side. Correct? How long a person can hold it? Okay. He wants to go to home. If he leave means again it will come to its original position. So to keep this in this stretched position, what we use some anchorages. Okay, here we use some anchorages such that it will the tendons or the cables will be under tension. Okay, so here the person will not be pulling. We have some devices for applying the tensions. Okay, so to keep this tendon in a tension position, what we use some anchorages. Okay, anchorage, a device generally used to enable the tendon to impart and maintain pre-stress in the concrete. Okay, what you mean by pre-tensioning? Okay, the word itself says pre means before. A method of pre-stressing concrete, okay, in which the tendons are tensioned. Okay, very important. The tendons are tensioned before the concrete is placed. Okay, so in a offline mode also, he will ask the procedure. Just I will give brief about it. Later we will go deeply. So this is your mold, okay, concrete casting mold, which is rested on the ground, and this is most important. Remember pre-tension and post-tension. So this is my cable or tendon or wire. Okay, so before placing the concrete, what we do, we provide tension, we pull it. So we provide tension, and after applying the tension, what we do, we anchorage it. Means छोड़ने के बाद भी वो वापस उसकी पोजीशन में नहीं आना है. So what we do, we provide some anchorages. After providing the tension, what we do, we place the concrete. So this is one beam. Okay, this is another beam. So this is another beam. What we do, we cast it. Okay, after 7 days or after curing period, what we do, we release this one and we cut these anchorages. Okay, extra rods what is there now, we will cut it. So this is called as pre-tensioning. Then what you mean by post-tensioning? Post-tensioning means we are applying the tension to the concrete after casting. So what do you do, we cast this beam. Okay, and before casting, what we do, we provide one small pipe. Okay, we don't call it as a pipe, we call it as a duct. Okay, I will show what is that one also. So this is a passage for a rod to go inside, and this is the cross section. Okay, this is a longitudinal section and this is your cross section. So what we do, we cast the concrete. Okay, after the curing period has been over, what we do, we pass the cable inside this duct. Okay, we pass the cable. After passing the cable, what we do, we apply the tension to the cables. Okay, this is called as post tensioning, a method of prestressing concrete by tensioning the tendon against the hardened concrete. Okay, after the curing period has been completed, then only what we do, we apply the tension, that is called as post tension. In this method, the pre-stress is imparted to the concrete by bearing. Okay. Next one, definition, pre-stress to concrete AIC committee. Okay. So concrete in which there have been introduced initial stresses of such magnitude. Okay, we have on solving problem we will see either it is 70 kilonewton, 10 kilonewton, 15 kilonewton. Based on this we have some problems. Okay, and distribution, that the stresses resulting from the given external loads are counteracted, okay, to a desired degree. Okay. In the reinforced concrete member, the pre-stress commonly introduced by the tensioning the steel reinforcement. So initially I have showed some example. This is your RCC. So before applying the load, it was like this. Okay. Here we can see we applied the uniformly distributed load. After applying, you can see the cracks has been, or the sagging of the beam you can see here. Okay, and this portion we call as it as a tension. I know you remember the basic things. The bottom part will be the tension and this will be your compression, correct? So here you can see the cracks are formed at the tension zone. The crack with under deflection, sorry, the crack with deflection under the dead load and full service load, means that is after application of your dead live load. See, in pre-stressed concrete member, it will be like, initially it will be like this, and here you can see the tendons, and this is your anchorage system. Okay. So after application of the beam, load, it will be like this. Means that you apply the load, correct? You apply the load. What it does, it counteracts the applied load. So, and it prevents the deflection of the beam. And here you can see you don't have any cracks at the bottom. Okay, this is the main principle. Principle of prestressing, offline mode, most important. Prestressing is a method in which compression force is applied to the reinforced concrete section. The effect of prestressing is to reduce the tensile stress. Means in RCC you have seen the cracks has been formed at the tension zone. So what we are doing, we are preventing that one to reduce the tensile stress in the section to the point till the tensile stress is below the cracking stress. Okay, thus the concrete does not crack. It is then possible to treat a concrete as an elastic member. Okay, the next point, the concrete can be visualized to have a two compressive forces, that is initial prestressing forces and external forces. These forces must be counteract each other. Okay, so these are the some basics. Important dramatic representation. So this is your pre-stressed concrete, PSC, and here you are applying the tension. Okay, means here you have a rod. So this is nothing but pressure, that is force upon area. Okay, can call it as FT or FD. In further problems we will see what you mean by FT. FT is nothing but the stress at the top, and FB will be stress at the bottom. It is given by P upon A, and if there are any applied loads, then we have different formulas. See, movement due to dead load, movement due to live load. Okay, these are the stress representations. in very first unit in SD2 or SD1, SD2 we have learned. Okay, so after all this one we can see we have large compressive and very less tension in the concrete. And you know the property of the concrete. Okay, it has high compressive strength and low tensile strength. So to determine the compressive strength, which experiment you do? You perform the cube test. Okay, 150 by 150 by 150. Okay, so from that you will come to know the concrete is, and the property of the concrete is that it is good in compression and weak in tension. Okay, so tensile stress test, which one you do? You prepare one cylinder. Okay, 150 mm diameter. So you apply the load, you can see the concrete will easily crack down. That because of that only we know that, remember this point in interviews also, they will ask this one: concrete good in compression, very basic important, and weak in tension. Okay, so we know that good in tension. Okay, but this is my beam. Okay, this is my beam. I know that the concrete is good in tension compression, so that I can apply the compressive force how much I want. But it is weak in tension, so the concrete cannot take tension. But your steel, okay, your steel, what we do? It will take the tension. So only what we are doing? We are providing the steels. Okay, so only we are providing the steels such that the concrete will take the compressive force and steel will take the tensile force. Correct? Remember this one, very important for all the aspects. So we know that the concrete is weak in tension. So here you can see we are reducing the tension in the concrete. Okay, this is most important. Remember it. And here you can see the prestressing is done at the center. Okay, okay. In the next figure, you can see the prestressing is done at the eccentricity. We will call E is nothing but the eccentricity. Means certain depth, okay, from the neutral axis. The total depth is say 300. This will be 150, and he will say that the cables are provided 50 mm above the bottom fiber. This is our bottom fiber. Okay, means that this is how much? 50 mm, and this will be how much? 100 mm. So if you provide the cable profile at this one, you can see again the prestressing force will be F upon A. Okay, the stress due to the dead load, live load, and this is the resulting compressive stresses. Okay. Now, so initially I have said that we have different types of wires, tendons, strands, and bars. Most important again, for if we ask any definitions in offline mode, wires means prestressing wire is a single unit. Very important. For if it is MCQs, he will try to confuse you. Wires means prestressing wire is a single unit made of steel. Okay. Next, what you mean by strands? Okay, strands is nothing but it is a group of 2, 3, or 7. How much? 2, 3, or 7 wires are wounded to form a pre-stressing strand. What they will do? They will take one steel, two steel, or 1, 2, 3, or 1, 2, 3, 4, 5, 6, 7. Okay, they form in this shape here, like this, and the group of steels, either it is 2, 3, 7, we will call it as a strands. Then what do you mean by tendon? Again, it is a group of strands. Remember, a group of strands or wires are wounded to form a prestressing tendon. Here it is a group of strands. Okay, remember this one. Next, bars. Bar can be made up of a single steel bar. Okay, the diameter of bar is much larger than that of the wires. Okay, most important one. Don't try to forget this one. Wire, it is a single unit. Strands, it is a group of wire. Okay, tendons, it is nothing but a group of strands, and bar is a again single unit. The definition, again, the concrete in which the reinforcing steel are stretched and anchored to compress it, and thus the increase in the resisting of the stresses. So we will see about the difference between the pre-stressing and RCC. Okay, that is also important from the point of view, for exam point of view. So in RCCB, uh, so in RCC concrete, above the neutral axis is the only effective, and concrete below neutral axis is ineffective. You know what you mean by neutral axis? So this is our neutral axis, and this is our neutral axis. Okay, the concrete above the neutral axis is only effective. Okay, and the below the neutral axis is ineffective. But in pre-stress, entire section is effective. So in that, how it is, we will see we have different types of numericals. We will see that one. Okay. The second difference is that because of self high weight is a long span is not possible. So if you want to make a long span, say greater than 8 meter, RCC cannot be used. Okay, but in pre-stress concrete we can reduce the, and main thing about the pre-stress concrete is that we can reduce this size also. Okay, say that this is my 8 meter beam, for example, and the depth is around 1.2 meter, and this is a RCC structure. But in pre-stress concrete, we can, the span will be the same. Okay, this is pre-stress concrete, and we can reduce the size up to 700 mm. This is 1200 mm, and pre-stress concrete is 700 mm. So the thing is that the section of the RCC is greater than with respect to the pre-stress concrete. And in RCC, high strength concrete is not needed. Okay. Here in RCC, high strength concrete HSC is not needed, but here we need high strength concrete because we are providing the compressive forces. If you see the thing here, high compressive compression is there. So, so that for that one, what we are doing, we are using high strength concrete. Okay, this is important. What he will ask the pretensioning and post-tensioning. Okay, before only I have given gave you example like this. This is a pretensioning one. In post-tensioning, a duct will be there. Okay, I will show you what you mean by the duct. Okay, here you can see this is our college building. Okay, sorry, in our college it is a school building. beside your hostel. Okay, the school building was constructed now. So this is a slab. Okay, here you can see the silver colors. Okay, these are nothing but the ducts. After pouring the concrete, the tendons will be passed through these ducts. I have some photos. Yeah, here it is clear. You can see the ducts. Okay, from here only the cables or tendons will be passed. So the first one is that pretension. Okay, don't get confused. Pretension, pre-stressed concrete. Okay, the beam or the elements are constructed on a stressing bed, and strand cables is placed between the two busters anchored to the stressing bed, which holds the force in the stretch cables. Okay, after stretching the cable with the hydraulic jacks. Okay, not the person will pull it. We have some different equipments. One of them is that hydraulic jacks. Concrete is placed in the forms around the cables and allowed to harden. Okay, when the concrete reaches the sufficient strength, the pre-stress force is transferred to the concrete by bond. Remember, while asking the difference between pre-tension and post-tension. Okay, see in uh, in next figure I will show you. When the steel stands at the ends of the beam is cut loosened from the busters. So here you can see this is my end abutments. Okay, these are my steel tendons. Red color whatever you see, these are your either tendon, cable, wire, strands, etc. So what we'll do first, we will keep place these tendons. We apply the tension. So we apply the tension to this cable with the help of the hydraulic jacks, and we provide the wedges or end anchorages. Okay, so after that what we do, we place the mold and we cast the concrete. Okay, we cast the concrete. Afterwards what we do, we cut the tendon. Okay, so the entire tension will be transferred to the concrete. So here we can see this red color. After that it will be transferred. This is the what, pre-tension, pre-stressed concrete. Okay, and one more thing, here you can see either it may be a tendon, strand, wire, or bar, whatever. It is coming contact with the concrete. Okay, there is a contact between the, here you can see there is a contact between the tendon and the concrete. Okay, but in case of post tension, okay, there is not contact because the tendons are passed through the pipes. Okay, it is not a pipe, it is called as a duct. Okay, so the tendon is not coming with it is not touching, or it is not coming interface with the concrete. Okay, keep it that in mind. Okay, and here there will be a frictional bond. Okay, frictional bond between the wire and the concrete. Okay, that is the most important thing. Okay, these are some of the examples for pre-tensioned concrete beam. Here we can see the cables, the bars are given tension. This is your beam or slab. Okay, this is a single unit, this is a slab. Okay, in post tensioning See, these are the rolls of cables. Here you can see the ducts. Okay, what they do, they passes the strands. Okay, here you can see this is a strand. With the help of the hydraulic jack, they apply the tension. The procedure I have already explained you. Initially, this is the framework. Okay, centering work is there. They provide all the cables, and also laying the cables we have uh, certain heights. Okay, at what height or eccentricity we have to keep. For that one, what we call it as a cable profile. Okay, this is your beam. Sometimes what do we provide the cable straight, we provide the cable like this. Sometimes we provide in a triangular shape. Okay, we have different cable profiles. After laying the concrete, what do? We apply the hydraulic jack and we provide the tension. So after hardening of the concrete, after hardening of concrete, what we do? We apply the tension. So that is called as post tension. So tensioning devices are there. That is, one is mechanical device, hydraulic device. Remember for MCQs, okay. For offline, chances of getting this question is very less. But MCQs, it will 100% he will ask. What are the tensioning devices? The first one is mechanical device. Second one is hydraulic device. The third one is electrical device. Fourth one is chemical device. Okay. And we have some of the popular post-tensioning systems. Okay, remember post-tensioning system. Okay, you know that father of prestressed concrete, that is Prestressed. He developed one system. He developed one system. Sorry, on anchoring devices. Here you can see it is a combination of male and female. Okay, whatever you take, it is the thing in the universe. Whatever you take, it is the combination of male and females. Okay. For example, your pen, it consists of pen and cap. Okay, so you know what is male and what is female. So here also we have male and female. This is the female part, or the pink color, whatever you see, female anchorage with the steel spirals. Okay, and this is a male part. Okay, fluted male cone. Clear picture means here you can see the cables will be passed here. Okay, so it acts as a wedge. Okay, act as a wedge, and this is your duct. Another different type we have is the Mangal Dalton system. Okay, here this is your steel plate. Okay, these are your tendons. After that, what they would do, they bring and they keep it here. Means they hold the cables in a tension form. For your all system, it is also like same thing. Lee Meckel system. Okay, remember these important things also. In MCQs, we may ask which of the following or is or the anchorage post tension. Okay, not pre-tension, post tension anchorage system. One is Perenship, Mangal Barton, okay, Griffald, Goodall system, and Lee Meckel system. Okay, if you are interested, I will provide you the notes. In my notes it is there, and in textbook also is there. You can refer it. Then what are the advantages of prestressed concrete? Okay, lower construction cost. Okay, thinner slab. Initially, I have said that we will reduce the size of thickness of the members. Thinner slabs, which are especially important in a high-rise buildings, where floor thickness savings can be translated into the additional floors for the same or lower cost. Fewer joints, okay, only less joints will be there. Long spans, this is also most important. This point and this point, longer span length increases the usable unchambered floor space in the building and parking structures. Okay, again fewer joints. Disadvantages is the major problem with the prestressed concrete is that needs special construction machineries like jacks and anchorages. Okay, next, advanced technology and strict supervision is very important. For concrete prestressing, high tensile reinforcement bars are required. Okay, so high strength concrete is required as well as high tensile strength bars are required. Highly skilled laborers are required here. Okay, so this is a box girder. Here we can see the tendons. Okay, these are the tendons. What are tendons? It is a group of strands. Okay, what is strand? It is a group of wires. These are the some pre-stressed electrical poles, pretensioned electrical poles. This is also another example for pretensioned concrete. So, method of pretensioning. Initially, I have said that first what we have the mold. We keep the tendon both the side. We anchor it. We apply the tension. Okay, then we place the concrete. That is only it is explained here. Anchoring the tendon against the end of the abutment, placing the jacks, applying the tension, casting the concrete, cutting the tendon. In post-tension, casting the concrete, placing the tendons, placement of the anchorages, applying the tension, seating wedge means we apply the wedges. We apply the wedges like this, seating the wedges and cutting the tendons. This is the method how we cast it. Again, it is explained here. In post tension, you can see this is our duct. These are some examples. So, what is the time? Okay. So, anybody having doubt in the theoretical part? Comment yes or no. Anybody having doubt in theoretical part? Alan, actually, AIC is nothing but American Constitution Institute. How we have IRC, ISI, Indian standards, it is like American standards. Okay. Yes, Ashish.
नाही सर चुकून झालंय.
Hoop tension is nothing but I will show you. 1 second. If this is your Okay. For example, this is as a water tank. Okay. So whenever you pour water here, okay, whenever you apply the water or liquid anytime, some forces will be horizontal forces. The liquid will be acting on the walls. Okay, so that is nothing but the hook. They will try. If I draw the cross section, okay, this is your cross section of this tank. Tension means the tension which are acted due to the liquid or the inner, means this is a hollow one. Okay, our RCC will be of the fully packed solid one, but in case of barrels or water tanks, water retaining structures, it will be hollow, okay, inside. So the tension which are acting on the walls, so those are called as the hoop tensions. Anybody having doubt? So in next class we have numericals. Okay, so very simple are there based on formula. Before that, attending to the next class, be perfect in how to determine the modulus of velocity, and second modulus, moment of inertia. Moment of inertia is most important. Ixx, Iyy. Okay, moment of inertia is most important to solve these problems. Okay, so while attending to, and it is a very basics one. Okay, not that much complicated. Only the thing is that you have to remember some basics, whatever you have learned in the first semester. That is engineering mechanics. You have learned about how to calculate the CG, okay, and how to calculate the model moment of inertia. So those are, and section modulus. For example, if you take this one rectangular, this is B, this is D. So, for example, this is your rectangular beam, this is your width, and this is your depth. Okay, what will be the moment of inertia? BD cube by 12. Okay, you know how to calculate these things. Next, Z modular section modulus. Okay, section modulus, it will be BD cube by 6. Okay, so you have to remember these things, or Z is given by I upon Y. Okay, remember these things, or do one thing, just glance. If you have any notes, means just what to do, you just glance whatever you have learned about the moment of inertia, how to calculate the CGs. Because if we have rectangular sections, means that rectangular beams, it is not possible. If we have I sections, okay, if you have I sections, means you have to calculate the value of I. Okay, then only you will get the value of Z, that is I upon Y. How to determine the neutral axis. Okay, remember all those things. I will also explain. If you get some time, means try to go through it. Okay, so anybody having doubt here? If not, you can comment your roll numbers and you can leave the class.